Okay, I'm Francesco Fontanella from the University of Cassino in Southern Lazio, and I will present my paper titled Using Genetic Algorithms for the Prediction of Cognitive Impairments. Okay, here is a very brief outline of my presentation. I will talk about cognitive impairments and Alzheimer's disease, and then how handwriting can be used to predict actually cognitive impairments. Then I will explain how we define the protocol for the data collection from the handwriting of subjects. Then briefly the segmentation, feature extraction, then the proposed system for analyzing the handwriting of cognitive impaired subjects, and then some experimental results and conclusions. Okay, what is it, cognitive impairments? Cognitive impairments, the definition is a cognitive decline, okay, in which this decline is greater than what expected with respect to the age and education. It actually does not interfere deeply with the activities. Then it's not so simple and easy to detect, okay? However, it may evolve in more than 50% of the cases, it evolves in dementia disease. And then it's really important to identify this kind of impairments very, very soon. And moreover, it is at the high risk of progression in Alzheimer's disease, you know. And then it's a symptoms, a prodromal symptoms for this disorder. Okay, as for the Alzheimer's disease, you know, unfortunately, it is very common and very known. It is the cause of, it causes about the 70% of all cases of dementia. And at the early stage, it creates problems with the short-term memory, and then later with the language disorientation and actually with the behavior of the subject, the patients, okay? And you know, the incidence of AD strongly increases with age, okay? Then unfortunately, it is expected that will dramatically increase in the next decades, you know, because the lifespan is increasing worldwide. This is a good thing, but this is one of the negative aspects of this. How actually it is diagnosed with cognitive tests and some invasive biomarker tests. For example, cerebrospinal fluid test, that is a very invasive test. Actually, the true diagnosis of AD can be done only post-mortem, because they have to analyze the cerebral tissue of the subject, okay? These are all, these diagnoses are never the certain diagnosis, okay? You know that it is a neurodegenerative, there is no cure, but an early diagnosis may really improve the effectiveness of these of the treatments that are currently available that actually relent the disease. Okay, then, but it is actually a really challenging task. Okay, as for the handwriting, you know, everyone is able to handwrite, is the result of a complex network of cognitive, you know, and also motor, perceptive. You have to perceive while you are writing. There is the perception of what you are writing, and the motor, you correct your motor, your movements while you are writing. Then it is one of the first skills that is compromised by any kind of cognitive impairments. Also, in the first paper of Alois on the Alzheimer's disease, it noted also some alterations of the handwriting of the first patients. Okay, here are some two references about cognitive impairment and also Alzheimer and handwriting. How this handwriting is analyzed? There are both static and dynamic features, okay, like the position, very simple features about these static features, the dimension. Also the dynamic features are very important, like velocity, acceleration, and even the jerk, okay, very, very important feature. As concerns the state of art on how the handwriting is analyzed in order to predict this disease, we found that most of these studies are in the medical field by psychologists and physicians, okay? Very few of them, at least until 1 year, 2 years ago maybe, few of them use the machine learning tools with classical classifier okay, tools. And these studies, with the typical approach in the medical field, they use these statistical tests with like ANOVA, for example, in which they investigate, the relationship between the single variables and the disease, okay? And, there are few and there is no analysis of, we expect that the relationships between this disease and many of these variables can be actually nonlinear and complex. And most of these, if you use a simple test that only analyze and test the single features, you may have a problem in terms of prediction. Okay, it's not so. Then only using analyzing this nonlinear interaction, you can improve your performance in terms of prediction. Okay. Then we defined a protocol. Okay. For the data collection, okay, with the aim of studying how these cognitive impairments affect the handwriting. And for doing so, we defined, this is the first protocol in which we have tested 25 handwriting tasks, okay? Because why in practically all the studies, few tasks was tested in order of 5, 8, 10, no more than 10, I think. Here, instead, we defined 25 with the aim of testing more of the cognitive skill that are affected by this cognitive impairment. Some simple task, like, for example, copying simple letters, numbers. Okay, we studied a lot of literature and put together several of these tasks. Then, for example, memory tasks. Each of these tasks affect uses different of our cognitive skills. Okay, then the aim of our protocol was to probe these different cognitive skills. Okay, each of these tasks involve different cognitive skills, and then we want to test most of the skills that are affected by this kind of impairments. Okay, then we defined this protocol means that we bought a tablet. This is a Wacom tablet where, okay, you can see here in the figure on the bottom left. You write on simple A4 white sheets, okay, that are stapled on this tablet. The tablet, and here is an app that in order to transfer the file, okay, each of these tasks, here the patient is writing a simple phrase, okay, that are defined. Each of these tasks is on a sheet, and then it is transferred with the simple text file with the spatial coordinates that are the X and Y, and also the pressure. This is a special pen that is able to record the pressure. The tablet also records in-air movements. Okay, you know, when you write, when you move from left, suppose for how European or Italian, people, when you write from left to right, you sometimes lift up the pen from the sheet, and the tablet is also able to record until 3 centimeters from the sheet. Is able to record the movements. Why this? Because in the literature has been proven that also in-air movements characterize these impairments. And finally, why we chose this kind of tablet? Because for us it is much better, because instead of using a tablet, for example, a modern tablet in which you have a stylus in which you write directly on the surface of the tablet. Okay, it's much more natural writing on simple paper, white sheet paper. Okay, we, as concerns instead the data collection, we was able to collect 175 subjects. This is I think a huge the number for in this field, you know, because all the studies that have been done previously, only few dozens of patients have been collected. You know, it's not so simple to collect data from behavioral of patients, okay? Because you have to have a patient stay there and so on. As concerns the impaired patients, we went to an Alzheimer unit in Naples, okay, from a university hospital, and we matched the statistics of the samples, and the recruiting criteria was a clinical diagnosis by an expert at the head of the unit that made the diagnosis of cognitive impairment, okay, and then some cognitive tests. Okay, here then the diagnosis is cognitive impairment. For all of them, this was the first time that they went to the doctor. Okay, just at the early stage of their impairment. So it is a very important, because our aim is that of have an early diagnosis for our patients. Okay, here very, very briefly, we then defined two kinds of features: on paper and on air. On paper means when the pen is touching on the sheet. Okay, on the other side also the on air, and then we have split into different kind of features. In terms of strokes, the strokes are very elementary traits of our handwriting, okay? And then here the segmentation point, pen up and pen down, and when you go up and down with the zero crossing vertical velocity. Here are the features, okay, static and dynamics. I go ahead. Okay, here then is the system. Okay, we have here n is 25, you know, the number of our actual tasks. For each task, we have two data sets, okay, two kind of features for each patient, and we have trained two classifiers for each task. Then the total number of classifier of predictions for each patient actually is 50. And then we, in order to classify, we want to classify patients, okay, or subjects more in general. Then we use the simple majority vote rule in order to predict the cognitive state of the patient. Okay, then we have an optimization problem. We want to find the best subset of tasks that improve our overall system performance. That is the accuracy, clearly. This is a combination of the combinatorial optimization problem, you know. Then we want to find, okay, our first question was, can we reduce the number of tasks that actually is effective in predicting the cognitive state? Okay, then we use a GA, very simple GA. Clearly, our goals were, we want to maximize the prediction performance of our system, and at the same time, we want to minimize the number of tasks. Okay, then we use the GA here. Then the GA is able to select a given number of tasks, and then we still use the majority vote rule for predicting the final, the cognitive state of our patient. Clearly, a GA is is okay for this kind of problem, because, you know, the solution representation here is like a feature selection problem, actually, in which you have n here is equal to 50. Okay, we have 50 predictions, and then one for included or in the final, in the majority vote or not. Very simple approach, actually. Here is our GA is a very simple and standard GA, or a vanilla GA, as our reviewer defined our GA. As concerns the fitness function, we use only the training accuracy of the selected tasks. Very simple accuracy, very simple fitness. We will see that, however, it is still able to reduce the number of tasks. Here we use the 4 classifiers. Okay, we have to choose a classifier. We divided in 80% as a training set and 21 as a test sets. And we performed 3 sets of experiments with 50 runs. Okay, see here are the standard parameter with 1 over the number of bits for the mutation probability, very standard. And here are the first results. Okay, here on the upper part, you can see the train and text accuracy in order to test the generalization. We can see that for the decision trees and the neural networks that are very good generalization ability, that are very close to the train and test accuracy, not the same for the random forest or the support vector machine, okay, in which they was not able to actually to generalize on this kind of data. And what is very interesting is how the number below, you have the number of tasks of the best and average of the whole population, okay, that very naturally we can say, because again, in the fitness, there is no terms taking into account the number of tasks. But this seems that in order to improve the accuracy, okay, that is the only term in our fitness, we must reduce the number of tasks. Okay, we must, in order to get better. This is for all, very interesting, all 4 classifiers. Very, very good, very clear here, this trend for the decision trees, also for the random forest, but for all 4 actually. Okay, this means that we need to reduce the number of tasks. This is a good news. The bad one is, okay, we then have built this is the number of occurrences, okay? We want to find the more relevant tasks, okay? In order, here is the number of times that, for example, the task 8 has been selected in the 50 runs, okay? And here you can see that there is no task that is actually selected for all classifiers. For example, the number 8 that is very used for the decision trees or for the random forest is almost never used in the neural network and few used in the support vector machine. Then here, what we can see is that we have very different performances for the different classifiers that we used. And then there is no relevant tasks actually that are common for all classifiers. Actually, each classifier is able, uses different features and different models. And then this implies that there are no common relevant tasks. Okay. Here are some comparison findings. We compared our results with the baseline, actually, that is the majority voted, and the weighted majority vote, in which the weight is the training accuracy. And then we use the floating forward selection, that is a feature selection technique. Okay, very effective, because actually our is a feature selection problem. Okay, these are my conclusions. We presented this system for improving, that uses the GR for improving the performances, in which we have the handwriting analysis for cognitive impairment. Performs well in terms of generalization and number of tasks. The most relevant tasks actually depend on the classifier and outperforms these simple voting rules and the feature selection approach. Okay, I finished. If you want email, you can email me, or okay, actually also now clearly make me any question you want.
That's great. Thank you very much, Francesco. Really interesting work. If anybody has any questions, can you please raise your hand on the, and I'll try and see if anybody has a question there. Well, I've just got a question just while we'll wait for people to raise their hands, Francesco. So this is very close to work I do, and I have to say it's really impressive work you've done. I think you've done a great job at getting so many patients, and also getting them clinically assessed as well. And it's in the area of the clinical assessment I'm interested. So you mentioned there that you used mini mental state examination and MOCA, the Montreal Cognitive Assessment task.
Yeah.
You must have taken those as the ground truth for your supervised learning. And I was just wondering, because the MOCA and the MMSE give sort of like absolute results, number results, something like out of 20, isn't it? How did you use that ground truth to really train the algorithms? Did you look for the difference between the MOCA and the MMSE score to the?
No. We actually use them as a binary class. Okay, I think that most of them performed both MMSE and MOCA, and the MMSE has been also submitted clearly to the healthy control. Okay, because before to say that one is healthy, you have to test them, and we used the MMSE test for the healthy control. About the patients, I think that they had a battery of tests. Okay, several tests inside the Alzheimer unit. I said that two of them, I'm not sure about, but I'm sure about the MOCA and MMSE at a battery of tests actually, in order to be sure that they are cognitive impaired. A first diagnosis, okay, of cognitive impairments.
Okay, that's great. So we got a question here from Scotto. Hello? Scotto, you had a question? Oh, I've tried to unmute.
Actually, I raised my hand. Stefano Cagnoni.
Oh, hi, yeah.
Can I ask something
Yeah, sure, please go ahead.
Okay, actually, I would probably, the question is both to Francesco and to you, because I know you've worked a lot on this topic. And I've seen that Francesco has used mainly temporal features, even if taken from from pictures, from images, from handwriting. What would be other studies that are only related, that only uses the shape or the image analysis or the pattern analysis of the handwriting instead of using the temporal features? And also, since these are temporal features, did Francesco try to use some deep learning techniques like LSTM or something like that?
Yeah, great. Well, I'll answer the first one very quickly, and that there are a number of studies that look at just the structural features of the images, and they're obviously more constrained in some ways because there's so much information in the dynamic properties if you can capture them. But interesting what you said, Stefano. There's the latest project I'm working on. There's a huge motivation for just looking at the static features, because there are some data sets in some medical centers around the world where they've been taking these drawings for years, and they've got thousands of these drawings. And so the really exciting thing is, if we, from our knowledge of the dynamic properties and how these look in terms of the pen strokes, a really challenging task is whether you can infer some dynamic information from the pen strokes themselves. And actually, that sounds like it's impossible. But if you, for example, just take a pencil or pen and you draw a line very quickly and you draw one slowly, they do look pretty different. And so there are some clues there about a way of being able to do that. But I'll hand over to Francesco to answer the second bit of the question.
About we are also used. Okay, actually, Stefano, there are not images in our approach. Okay, we have only a sequence of points, of coordinates, but we are also working with a deep learning approach. We are building images, okay, and starting from the sequence of points, and then we are trying to predict. We are to train some deep learning classifiers, but clearly we have not so many data. You know, with deep learnings, we need more data. Actually, we are using a fine-tuning approach with some standard net, and not training a network from the scratch. Okay, we are still working on these. Okay.
Super. Right. Well, thank you very much, Francesco. A really interesting paper, and I think some really good work there. Certainly in terms of the numbers of patients as well, and very high scores. So I'll follow that with interest. Thank you. Right.
Hello. I would like to make a question.
Yeah, quickly, please. Yeah.
Yes. Since most people write down with the right hand, I suppose that the studies carried out in the paper come from patients who write down with the right hand. But have you done studies with people who write down with the left hand?
Yeah, we have also people with the left hand. And actually, we have not used these, this could be a features, okay, feature in order to distinguish them. But no, we also have people writing with the left hand. Okay.
Yeah, most of the...
We are not able, actually, we have not studied how the left or right hand affect the prediction ability or the way writing. Actually, it would be very interesting to understand if the hand that you use for writing, how, if it is affect the way in which your alterations given from the impairments, okay? Maybe the impairments may affect differently people writing with the left or with the right hand. Maybe we have few people, but we have some of them writing with the left hand.
There's actually quite a lot of work, historical work, going back many years, looking at the differences of left-handed people's brain arrangement anyway. So it's quite a complex study, but certainly my experience that, the tests tend to be applied for left-handed, but it's a big question. It's a good question, and it's a big question.
Okay,
Okay, right. Thank you very much.